These bar chart questions have been on the ACT for a long time, and they take a couple different forms. Now in this one, we're asked about weighted average. We're asked to find the weighted average of the number of ACT attempts. It could just as well be a median. Now let's talk about how these bar charts work for a second. So on the x-axis, you have the number of ACT attempts. That's sort of the value, right? That's the value, that's the categories we're going to sort the numbers into. Up the y-axis, up the graph, are the number of students, the quantity, the frequency. So in actuality, this bar chart and the bar charts like this that you'll run into are really frequency tables as graphs. So in the frequency table video, we tackled a median problem based on a frequency table. That frequency table could just be made into a graph like this, and you could ask the same question. Vice versa, we could take this bar chart, turn it into a frequency table, and ask the same question. In fact, there's a problem in the weighted averages video just like that. So for more on this stuff, check out the weighted averages video, check out the frequency table video, make sure you look at that section in the book, and also in the mean, median, and mode section, because that's where the math comes from. So because we have whole numbers, we're not dealing with percents or anything like that. I'm going to choose to calculate this average just like I would a regular average. Average equals sum over number. Now, the trap people fall into is that they either average the number of attempts, 1 plus 2 plus 3 plus 1, yeah, or they average the number of students. You don't want to do that. What you want to do is count everyone and their number of attempts. To do that, you have to count 2 ones, 1 plus 1. 5 twos plus 2 plus 2 plus 2 plus 2 plus 2. And so on and so on and so on. Now, obviously, the easier way to do this is just to multiply. Multiply is just repeated addition. Value times the number plus value 2 plus the number, so on and so forth. And then divide it by the total number. Again, like we've talked about before, you'll see that the total number is always given to you. Sometimes it'll be in the title of the chart. Sometimes it's in the question. In this case, it's in the question itself. So let's get to work on this. So we've got 15 high school juniors. That's going to go in the bottom. We've got 1 times 2, so that'll be 2. We've got 5 times 2, that'll be 10. We've got 4 times 3, that'll be 12. We've got 4 times 3, that'll also be 12. And then it looks like we have 1 5. So we add all these together. 2 plus 10 is 12, plus 12, plus 12, 36, plus 5 is 41. 41 over 15, and we can do the math on that, and that should work out to 2.7 attempts. So again, these problems look intimidating. Whenever you have value and number, you've got to count every value, which means multiplying the value times the number. Don't make these harder than you need to, but at the same time, don't grossly oversimplify this. You can treat it just like an average, but remember, everybody's got to be counted. That's why it's called a weighted average. Each value has a different weight based on the number of people that have that value, or the number of things. In this case, it's people. So that wraps up the data section. I really encourage you to take a look at the material in the book, because there's a couple topics I didn't think would translate well into videos. Bivariate data and lines of best fit, and then picking the right numbers. So you'll be given a table, usually with total column, total row at the bottom, and you're asked to find fraction, percent, probability of something over something. That's actually pretty tough. If you've taken the SAT, you've seen a fair amount of that. So definitely check that out, and definitely check out the problem set. These kinds of problems seem to be increasingly important. So definitely look at them.